Okay, let's get rolling. No, wait. My mic was in the wrong spot. I am so I'm so awake and with it right now. You would not believe how awake and with it I am. I just accidentally made OBS full screen and I don't know how to unfull screen it. Oh, everything's going perfectly according to plan. Let's see. Let's see if I can. What can I do? Probably escape. Yeah, no, that's not working. Thank you, though, heard it. Well, anyway, hello, Xenotime. Good to have you here. Hello, Astrolactopose. Hello, Uesugi Sagan. Hello, or Bushi. Should I call you Bushi? And hello, Herde. Nice to have you. At least I can still access my taskbar, which means I can see my PowerPoint, even if I can't figure out how to fix what horrors I have wrought. Was walking F11. I tried F11 too. I tried F11 was the Wait, it worked that time. It didn't work the first time I did it. Why did it work only after Xenotime suggested it? Oh well, I'm not gonna look a gift horse in the mouth. I'm not gonna complain. To a raid to farm HM, but there's a shiny fletchling vibe. Nice. I feel like I would have trouble finding it. Don't question the OBS spirits. You're right. I'm not going to question it. Wahaha. Okay, so, welcome to class. Happy to have you. Real facts, or whatever. First things first. If you have been looking at my Twitter, you would know that I have become immersed in a webtoon. I'm on, what chapter am I on? Do I even want to know what chapter I'm on at this point? I just finished chapter 68. I started it less than 24 hours ago, and I worked today. And I'm eager to get back to reading it. Luckily today is a short one. We did most of the we set most of the groundwork last week for this one, luckily, so I can get back to reading my webtoon. So close to 69. This is correct. Next up is episode 69. I wonder if anyone's gonna die. Anyway, let's put my phone far, far away from me so I don't get distracted, and let's talk about the repeated measures ANOVA as quickly as possible so I can figure out what's going to happen next in Omniscient Reader's viewpoint. This is actually, I guess I've read a webtoon before, because a friend of a friend was doing a webtoon, but then they stopped doing it because they decided they didn't like the plot. I bet they all survive. There's a lot of bit characters that have already died, so I don't want to take things for granted. I'm not sure how many of those. I don't even know what webtoon it is. Omniscient Reader's Viewpoint. I've heard that it's webtoon tier list stream when. Hi, welcome. I have not read a single full webtoon, Fi. I have read 2 webtoons, one of which, again, was a friend of a friend who decided to cancel it about probably 20-some episodes in, because they decided to restart it with a different plotline but the same characters. And then this one, I only started reading at around 7 p.m. last night. Webtoon tier list. There's 2 things on the tier list. Did they end it on a cliffhanger? No, they didn't end it on a cliffhanger, and the fact is, I actually know a lot of lore about their OCs, because friend of a friend. So, yeah, tier list of chapters in a specific webtoon. Tier list of episodes in specific chapters in webtoons. Oh my gosh, so I draw comics, like, that's one of my hobbies, and, like, tier list of panel arrangements, and tier list of specifically panel composition in the context of webtoon as a unique format. Because formatting pages for webtoon is completely different in terms of considerations and layout than formatting pages and panels for different types of medium. That would be fun. I would love to do like a tier list in general of like standard comic layouts, because like in America the standard comic layout is a 3x3, so like it, like, of course there's variations of it, not everybody follows 3x3, but sort of the standard comic page in American comics is 3x3 panels, and then with some variation depending on like the type of mood you're trying to set and stuff. And then in Japan the standard seems to be roughly 2x3 in my experience. And then Webtoon, of course, is a completely different beast, because like it's essentially each episode is just one long image. I'd have to read a lot more Webtoons by a lot of different authors to see if I can find patterns. Maybe one day I should just info dump about comics. 3x3 is trash in my humble opinion. I don't know. 3x3 can be useful because, so like I learned most about panel composition from the context of American comics, but most of the comics I've read are Japanese comics, so I tend to use a 2x3 layout, kind of some weird, horrible combination of the two. 4 S tier, that's right. I need to draw a lot of 4 I have that on my list of things to do, except they're not actually 4 because Phi wrote the scripts. And they're not all 4 Spoilers. I think Webtoons in print would be hilarious, like, have it like a receipt, yeah, or just a scroll, like a vertical scroll. That would be really funny. I think some Webtoons have gotten physical releases, and I really wonder how that worked out. But anyway, I need to hold off on drawing. I have a lot to draw, but my carpal tunnel is worse than ever, so I need to... Let's, you know what? We're 9 minutes in, and that means that's 9 fewer minutes I can spend reading this Webtoon. So we should get going. 3x3 for everything is trash. Using it surprisingly is totally fine. It's just overused and shouldn't be the default. Fair enough. I've seen some creative 4 My friend did one where there's a red thread of fate connecting all the panels and as they go down the panels. Nice! Panel layout, honestly, is one of my passions. Like, in terms of just, you can communicate so much information in what's going on in a comic from the panels alone. Like, I feel like I'm not claiming to be like a super expert in it, but I think I'm pretty good at panel composition. I've been complimented on my panel composition from people who like professionally read graphic novels for research and stuff. So I'm semi-confident in my panel composition, and like it's really neat. Like I could just like show, here's the panel setup for the page, and you can get a general idea of what's happening on the page sheerly from the panel setup with no dialogue or like things or any. You know who's really good at setting a mood with panel setup but also sound effects? Mokumoku Ren, the mangaka of The Summer Hikaru Died. I have never seen a mangaka better at setting the mood with page layouts and sound effects than Mokumoku Ren. Like, holy cow, I could learn so much from them. I have all the books that have been released in English. I want to buy the Japanese editions too. Maybe I can do that later. But it's so cool. You can do, this is not the talking about comics stream. This is the Repeated Measures ANOVA stream. That's what this is for. We're here to talk about Repeated Measures ANOVAs. Which ironically aren't actually used all that much in psychology lately, but if I'm going to talk about between subjects ANOVAs and Factorial ANOVA, I'm going to talk about Repeated Measures ANOVAs, so I'm sorry, we're doing it. We're going into it. All right, time to swing a silly metal sword, stick called a sword. Have fun with today's lesson. I'll check the bottom of it later. Oh, have fun, Bushi. Be careful with that sword. Don't hit anything with it that you shouldn't. And I hope that you have a lot of fun. And teach me your ways when you return. Whenever that... I want to learn how to swing a sword. I took one fencing class when I was little, and I had a lot of fun with it. Anyway, Repeated Measures ANOVA, and have fun, Bushi. Thanks for dropping by. Okay, so last time we had separate groups of people, 3 separate groups of people, or 4 or 5, but that was sort of like an independent t-test with multiple groups. But what if we want to do the repeated measures equivalent? What if we want to measure the same group of people multiple times? So maybe I'm measuring the same person across more than 2 conditions. I admit, so like I said, I'm reading Omniscient Reader's Viewpoint, and there's a character in there who's kind of like Subaru from ReZero, but not really. But essentially, like, when you die, you restart at a save point almost, or maybe even you restart at the beginning of the story. And I've been thinking, like, that kind of thing, that kind of like would be really interesting for a repeated measures design. Because, like, everything's the same except for the one person who goes back and reverts with their memories. Like, you could do a really cool repeated measures design like that, except unfortunately, usually the reason people are going back in time is because they've died, like, with Subaru or this character in Omniscient Reader's viewpoint, and therefore it probably wouldn't be all that ethical. Anyway, but that would be a really clean repeated measures study. Super clean. I guess it would be cleanest if you could erase the memories of the person when they go back in time. I feel like I've read a story like that, where somebody went back in time, but they didn't have the new memories after they went back in time. But, it invaded! It invaded wins again! Okay, anyway, I'm way off topic. Okay, sorry. Anyway. So let's say we have a design like this. This is a repeated measures design. Let's say I wanted to see if I watched more anime during the pandemic than I did at other times. I could track how many anime I watched in different years. So I can look at, say, how much anime people watched before lockdown, during lockdown, and after lockdown. And I could do this over like many different time points. This is a full 6 time points on this one. Now that means I have essentially 6 different conditions. You can think of it like having 6 different conditions here. Could I use a series of t-tests here? Or rather, should I use a series of t-tests to compare all of these time points to all the other time points? Would that be a good idea? Supervillain has the power to erase memories suddenly received hundreds of messages from psychologists wanting to use their ability. I know, right? I think psychologists wouldn't fall for that, but you know, I lean towards no. You're right, Heraday. We wouldn't want to use a lot of t-tests. And it's the same reason why we wouldn't want to use a lot of t-tests for the between treatments ANOVA. Because if we do a lot of t-tests, we just jump into doing a lot of t-tests to do all our comparisons. And with 6 conditions, that's a lot of comparisons. We would really increase our type 1 error rate, right? We really increase our chance of a false positive. Astrological says, I mean, if we can give it back, that it would probably be fine. Maybe the memory. I wonder. Because, like, depending on how much free reign we give them when they don't have their memories, like, what if they, like, forget that they're married to somebody and really hurt their spouse's feelings? I feel like that would be, like, undue emotional distress. So if it's only within a lab environment or something, that we erase their memories and we have informed consent from them and we don't think the repercussions will somehow extend beyond the thing, maybe we could do that ethically. But then again, I don't know if that counts as, like, risk within a day-to-day life. Man, you're making me want to redo that, like, how ethical... No, last time I ranked anime scientists based on, like, how good they were doing science, and part of that was ethics. But it would be fun to look at, like, various, like, so-called experiments that mad scientists and stuff do in anime and, like, see, would an ethics board approve that? Maybe that's another, like, streamer video idea. Would an ethics board approve this and why or why not? That could be fun. Maybe I could do a collab with Psy with that. I don't think she's finished her, did she finish her ASMR reading of, what was it? It was some document related to research ethics. Anime. That would... Oh, she did finish reading it? But I could invite her along anyway when she's done with her thesis scramble. Anime ethics board. I've got to set it up like an anime. The Helsinki Declaration. Yes, that's it. That's what I was thinking of. we could just... You know what? Let's get... I should invite all of V-Theorem who has dealt with ethics boards before and just drag you all in and be like, hey, how many of you want to just, like, pretend to be an institutional review board reviewing all these mad scientist things that have happened in anime, and we can figure out which parts of ethics they're breaching and not. That would be very fun, I think. I think that's a great idea. I'd do it alone if nobody wanted to do it with me. But anyway, okay. So, repeated measures ANOVA. Let's get through this first. Let's get through the repeated measures ANOVA before we start thinking about future things to add to my ever-growing to-do list. Okay. So, the approach here is pretty similar. We're just taking the ANOVA logic that we learned about last time, and we're adjusting it to deal with repeated measures, that we're measuring the same people multiple times. This way, we are adjusting the ANOVA, so now it can account for individual differences. Because we have the same people measured multiple times, we can account for individual differences between those people. If this person's high on depression at time point 1, 2, 3, 4, and 5, then we know this person's probably just depressed. And we can account for that and factor that out. Or like say, that's no longer error. We've explained some of that. Because we've explained some of that, because we can account for individual differences, say this person's always higher up on the dependent variable, or this person's always lower down on the dependent variable, because we can account for that, we have more statistical power. We're explaining away some of the sampling error just due to the fact that, well, these people are different. They're different from one another. Because we can do that, we have more statistical power than a between subjects design. It is easier for us to reject the null in a repeated measures ANOVA than a between subjects ANOVA, because we're explaining more of the variance. We know not all of it's error anymore. We know where some of those differences between people in the same condition come from. It's because they're different people. This also means we don't need as many participants for the same study because we have more statistical power. We don't need as many people in our study to get the same or better results than we would have with the between subjects study because of that, which is nice. So, null and alternative hypotheses are exactly the same as they were for the between subjects ANOVA. The null is still, imagine you're the subject and you read the paper you're in, it's just like subject questions results are explained by the fact that they're just depressed. Maybe this is why we don't report results for individual subjects. So that, I've actually participated in a lot of studies, and I don't think there's ever been a case, even when I asked to see the results of a study, that they actually told me the results of their study. Part of it is that participants have to remain anonymous. So, like, even if you were reading the paper, unless they, like, said something that somehow you knew you said in the paper, or you knew you said on the survey, and somewhere were able to identify yourself, they wouldn't know it was you they were talking about, and they wouldn't notify you that the paper was published. So if you happen to stumble across the paper, even if they reported your individual data, you might not even recognize it as yours. So they might not know if they say this one participant was depressed. But yeah, the way that it's calculated, let's say I did have an individual in my study who was like severely depressed, so they were always scoring high on depression. I would not necessarily see that unless I went through every single individual participant in my study. All of that's handled inside the ANOVA calculation, so I'm not necessarily seeing that at all. The person who's doing the study is only seeing the overall results, not any individual participants' results. If that's comforting. Usually there's not much reason. With this type of analysis, there's almost never a reason to look at an individual participant's responses just on their own. Every once in a while, though. But usually no. But that would be pretty rough. I'm trying to think of if there's ever been a case where, like, sometimes if I'm doing, like, a qualitative study, I'll quote people. Like, I'll quote some of my participants, anonymously, of course. I can't attribute it, because I don't know who the person who said it, but, like, I will quote people, and I'm wondering if I've ever had a case where, like, somebody who I quoted saw it, or, like, if there's ever been a study where I was quoted and I saw it and recognized it. I think that has happened. I think I participated in a study. I happened to see the results presented, and I'm like, oh, that was me that said that. So what you're saying is that psychologists have the ability to see who's depressed and needs help and then intentionally don't look and forfeit the chance to help them? No, not necessarily, xenotimes. So, like, if I'm specifically studying depression, and let's say I have some sort of measure of, like, if I'm specifically studying something severe like that, and let's say I'm taking measures of, like, likelihood of self-harm or something like that, a lot of those studies have ways built in so that the researcher themselves, and nobody else, only the researcher, can identify the participant. So if the participant needs help or, like, seems like an imminent danger, they can get that participant help. And a lot of these studies also, at the end of the study, will have a whole page of, like, here's all these resources that you can contact if you're having trouble. So depending on the type of research you're doing, the type of questions you're asking, the things you're measuring, you might be able to do that. You're mostly just, I figured you're mostly just pushing, but I thought maybe people would be curious. But if you're looking at a spreadsheet, wouldn't you notice someone unusual? Not necessarily. Like, a lot of the time, we don't actually look at the spreadsheet in much detail. We just load the spreadsheet into the analysis program that we're using and then have it go. There are tests that we can use to find unusual individuals, but I think the type of examples I'm talking about wouldn't usually pop out on those tests. We wouldn't usually consider them unusual. Only R knows, yeah. Sometimes if they're really unusual, you might spot something. So let's say sometimes you might notice that like somebody's always responding on the highest end of they're just saying yes to every single question. There are ways that you can notice that and point that out. And like what I do, some of the places that psychologists get data online, like online survey platforms, there are a lot of people on there who are just there. Well, maybe not a lot of people, but there's a proportion of people who are on these survey platforms just to get the money that you get as a reward for completing the survey. And they don't actually care about the survey or the data they're providing. So they'll just provide really, really shitty answers that aren't actually useful. They're not actually taking the survey honestly. And there are ways of identifying that. So like if I run a survey on one of these platforms, I'll add a question at the end, like, what's your favorite movie or something like that. And then what I do when I get the data in is I download the spreadsheet and I read through all the responses for what's your favorite movie. And then some people will say something that's not a movie. They'll say like Spider-Man or Avenger or something like that. And then I will go through and then I'll look at their response more closely. I feel like the data from that VTuber one that you looked at a while ago could be used to work back to the participants. It's entirely possible that that one could potentially be identifying, which is kind of concerning. That data is publicly available. It's that one at that point would be considered archival data, and that data was collected for practicing machine learning, I believe, which means that it probably didn't go through a review board, which isn't great, but it's currently publicly available data. So at this point, it's considered non-human subjects data. It's a bit weird. We had these surveys of how good our teachers were in high school. You would have the same questions, but flipped, and you couldn't just say AAA without it being really obvious. Yeah, that's one of the ways that we get these people. There are ways to like detect if somebody's just answering the same way. Like a lot of scales of like various things. Like I know was the Rosenberg self-esteem questionnaire one of them? Maybe. But there's these things in a lot of scales and stuff that we use in psychology called reverse scored questions, where like, let's say I'm measuring anxiety. I might have a question like, or a statement like, and they have to rate it from like strongly disagree to strongly agree. And it's like, I feel anxious all the time. I feel tense. I feel this. And you'll have a lot of questions like this where like more agreement indicates more anxiety. And then you'll have a question like, I feel very calm, or I feel peaceful. And that's a reverse scored item. And if you see somebody's answering like maxing out the scale 5, 5, 5, 5, 5 on every question, including the reverse scored ones, that's an indication they're not paying attention, because they're simultaneously saying they're incredibly anxious and incredibly calm at the same time. So we have ways. Yeah. That's exactly what they were doing in high school. Exactly. That's exactly what they were doing. They were doing it as kind of like, are you paying attention? Or are you like, actually bothering to answer these things properly? Mm-hmm. I'm all out of my beverage. Okay. But anyway, the null hypothesis for repeated measures ANOVA is the same. The null would be there's no difference between the conditions or across time points. And the alternative would be there is at least one difference between at least two of those conditions or two of the time points. People just wanted to get done with it and eat the brownies our math teacher bribed us with. That's how I feel about this low quality data on these survey platforms. It's like people don't want to actually take the survey. They just want the monetary reward for taking the survey, which is unfortunate. And like, that's a whole other conversation about like balancing the amount of money you give people for taking a survey. So it's not so much that they might start acting weird about it, but it's not so little that you're not fairly compensating it. There's a very difficult balance there. Anyway, okay. So the between subjects ANOVA had two sources of variability. The survey method tier list, that could be fun. I have so many tier lists that I want to do. One tier list that I want to do is like APA style rules. I want to rank them from like this is a weird rule, but this is a useful rule to why does this rule exist. I would like that. I think that's one of the things that I have on my list of things I'd like to do in the future. Tier lists are so much fun to do. I would love to do more tier lists. Anyway, okay. So, the between treatments variance. For the between treatments ANOVA, this was the effect of your independent variable with some error mixed in. And actually, it's calculated the same way for repeated measures ANOVA. The formula is exactly the same. It's calculated the same way. We think about it the same way. This has not changed. This is the sum of squares between treatments is still the sum of squares of the differences between your 3 or more conditions. So that's differences due to your independent variable and then some error mixed in. The thing where repeated measures ANOVA get a bit different is the within treatments variance. We still calculate the within treatments variance the same way. It's still the sum of squares in each condition all added together. But we do a little extra work now. So on the between treatments ANOVA, we just stopped here, and this was our estimate of error. Just any variance within the same condition. People being different from each other within the same condition before, that was just our sampling error. But now, we know a bit more about our participants, so we can explain away some of this. We know that not all of this is error anymore. Some of it's individual differences, so we get to do a bit more work. But first, I remember using the point that students answering a poll emailed to their school email are probably the type of people who are happy with the school while helping out a school press campaign. Yeah, there's a lot of problems with bias samples. There's this one really interesting study I talk about in one of my classes. It was looking at reducing prejudice towards transgender people. And it was an intergroup contact and empathy building intervention. So what they did was they had people knock on doors in Florida and sort of essentially say, well, can you think about a time where you felt like you were being treated unfairly, or like you felt like you were being singled out, or something like that, or when you felt like people were treating you differently. And so they did this empathy building exercise, and they found that even, was it 6 weeks or 6 months later, that the people who got this intervention were displaying less transphobia. And that was incredible. But of course, the trick is, these are people who are willing to open their door and have a 5 to 10 minute conversation with a complete stranger. Anybody who didn't do that was not included in this study. So, like, at the end of the day, you're gonna have a biased sample. You can only include people in your study who are willing to be in your study and who are willing to engage with your study. And at the end of the day, that's gonna be a very specific type of person, you know? Kind of sucks, but it is what it is, you know? We can't force people to take part in our studies. We have ethics now. So if we want to be nice, we're never going to get a truly proper sample. Hey, Water Knight. Guess they were just unwilling to change. I don't know. They didn't actually know. Like, I mean, think about it. Like, if you were in that study, if somebody knocked on my door and said, do you have 10 minutes to talk about, to me, a stranger? If I saw somebody knock on my door and I didn't recognize them, I wouldn't even acknowledge them. I would not. I'd look out my peephole. I would make sure that they didn't know that I was home. And if I saw a stranger outside my door, I simply would not answer it. It's not that I wasn't willing to change. I might be very willing to change, but I don't want to talk to a stranger. I don't want to talk to a stranger. I'm scared of strangers, you know? So it could be that there were quite a few people who were who would have been happy to listen, but also they didn't want to talk to some random stranger who was knocking on their door, you know? Or maybe they just weren't home. Like, there's a lot of other things that could have been going on there. It's complicated. Anyway. Okay. So, before, the within treatments variance was our estimate of error, but now we can explain away some of that. We know some of the differences inside the same condition are because these people are just different from one another. So we're going to take our within treatments variance, the variance inside of each condition, the differences between participants in the same condition, and we're going to split it up into 2 pieces. The first is the between subjects variance. This is a piece of the within treatments variance, so we've cut the within treatments variance into 2, and the first piece is the between subjects, and this is the variance that accounts for individual differences. This is how we control individual differences. So The between subjects variable. Just learn lockpicking. I don't think the IRB would like that very much. I don't think the police would like that very much either. There are some things that are unethical for research but legal, and I think that is both unethical and illegal. Okay, anyway. So for the repeated measures ANOVA, this is a type of variance that is variance between subjects. This subject is always scoring high on your dependent variable. This subject is always scoring low on your dependent variable. This person's always kind of in the middle for your dependent variable. So the variability between subjects. You can think of this like in terms of, say, energy levels. There's some people who are always really energetic, or almost always very energetic. Some people who are almost always pretty tired. You know, it's just looking at how much variation there is in your dependent variable between people in general. Here's the formula for this notation. We're not really going to go into the calculation of this because I'm giving you the formulas, but again, this isn't a very commonly used test in psychology these days. Usually at this point, you'd be doing some kind of like mixed ANOVA or maybe even probably a regression. But if you want the formula, it's there. Now, we have the within treatments variance that we've split into two. The within treatments variance is the variance of between people within the same condition or at the same time point. Your mind immediately went to electron orbitals when he said energy levels. I get that. Sometimes my brain goes to really weird places. It's salience, you know? Whatever's at the top of your head is going to color your perception of ambiguous wording, right? All right. So we split the variance in the same treatment into two pieces. The first piece, of course, is the variance we can explain by the fact that people are different from one another. What about the variance that's left over, though? So this is the within treatments variance. This is one part of it. Oh, hello, Rain. Welcome, welcome. Happy to have you. Whatever's left over after you've factored out those individual differences, whatever is still in the within treatments variance after you've gotten rid of variance just due to your participants being different from one another, whatever's left over is your error. That's your new error term. It's just whatever we can't explain. So the overall within treatments, ironically, I got clocked as doing A-level chemistry by a lab technician for by saying orbitals. You know, how we're learning how to break into people's houses in order to help them build. There's no order. We're not doing that. We're not doing that. How do I keep bumping into my favorite people? There's a strong community, it seems like. There's a lot of people who go to a lot of the same streams, which makes sense, you know? It's an individual difference. It's people with intellectual curiosity who also like VTubers. And some of whom are VTubers. we somehow flocked together a little bit. Pun unintended. Oh gosh. Anyway. So we have our within treatment sum of squares. This is just noise within the same conditions. Some of that is due to individual differences, and we can explain that away now. We know where that's from. It's just from the fact that people are different from one another. Some people are always high on this. Some people are always low on this. We've explained that. But there's still going to be some differences in the same condition that aren't explained by individual differences. That's our noise. That's our new estimate of error. We don't know where it came from. We're just going to chalk it up to sampling error. So we've split our within treatment sum of squares into variance due to individual differences that we can explain, and then whatever's left over, error. In other words, the sum of squares error is literally just whatever's left over. You take your within treatments variance, you factor out variance due to individual differences, whatever's left over that isn't explained by individual differences, that's our new error. All right, so that's all of our sum of squares. Our degrees of freedom between treatments is pretty much the same as it was before. You take the number of conditions, or in this case, time points. Sometimes it's time points, sometimes it's conditions, and subtract 1. So before I showed you like the amount of anime people watched over a 6-year period, we had 6 different years. Our degrees of freedom is 6 minus 1 or 5. If I'm only looking at like before, during, and after, that's 3 time points. 3 minus 2, or 3 minus 1 is 2. I love how the subscript for individual differences is BS. Me too. It is pretty funny. My brain's stuck on the German election. I saw SSW and was like, oh, the political part. That's a political part. I need to get better at... Actually, I'm gonna be honest, I really don't want to think about politics more than I have to right now, which I know is not great. But, like, I pay attention to politics way more than is good for my mental health already. But it would be good to study up on what's going on in the world, but also my therapist has told me to stop. Anyway, I know, right, Fi? I know. Pain. Pain. Yeah, it can really eat up your brain, unfortunately. I've now scheduled a time in the day. During that time, I am allowed to look up and read about things related to politics. At other times in the day, I'm no longer allowed to do that. I have scheduled my misery politics time for the sake of my sanity. You're good, I had to hard mute on my Fetty account. Oh, yeah, that's, yeah. Unfortunately, I've done a lot of political psychology. So, like, I dedicated, like, a good... most of my PhD, I paid very close attention to politics, and it's become a habit now. Because, like, I had to for my research, you know? So now it's just... Let's talk about repeated measure ANOVA, degrees of freedom. Work-related. It genuinely was work-related. Yeah, keep up with the stuff I'm not happy about. Yeah. All right, anyway, the within treatment's degrees of freedom is also the same as it was before. It's your total... Okay. So things are going to get a bit weird. So before big N was the total number of participants you had, and small n was the number of participants per condition. Now we have the same group of participants across all our conditions. So big N is the total number of observations that we have, and small n is the total number of participants, because that's the number of observations you have per condition. Let's say we have 3 participants and 3 conditions. Big N would be 9. I have 3 observations from 3 people with 3 observations each, and then little n would be 3. I have 3 observations in each condition. So it's gotten a bit weird, but this is still big N, the total number of numbers you have, the total number of observations you have, minus K, the number of groups. So, you know, time your derailing skills are doing really well today, I guess. I'm always easily derailed. Let's be real. I could not be a train because that would be a horrible disaster. I would be off the rails all the time. I'm not a train, I'm an all-terrain vehicle. Wait, wasn't ATV the name of the moth in that Twitch Plays Pokemon of the Venomoth? This is perfect. I really am an ATV. Okay, anyway, obscure, out-of-date references aside. Now we have 2 more degrees of freedom. So we have the sum of squares between subjects, and that needs its own degrees of freedom. It does seem very easily to derail the Psych V theorem members. You're not wrong. Me and Psy are both very easily derailed. Don't turn to dust, Fi, please. I'll mail you some gasoline to eat then. Please don't. I think that's illegal. All right, so between subjects' degrees of freedom accounts for the number of participants you have. And remember, this is the number of participants we have here is actually relatively small because it's the same group of people in each condition. So the number of participants we have here is small n, the number of overall people we've got. We're just measuring the same people multiple times. So let's say I've got 5 people total that I'm measuring multiple times. Little n is 5. I've got 5 observations per condition, 1 for each person. In this case, my degrees of freedom would be 5 minus 1, 4. And then finally, we have our degrees of freedom error. Our degrees of freedom error is whatever is left over from the within treatment's degrees of freedom after you factor out the between subjects' degrees of freedom. So it's the same deal as the sum of squares error. It's just whatever is left over from the within after you factor out the between subjects. Then we have our F ratio, our F value. This is the final step for any given ANOVA. This is the number that we have to use for our F test. We divide the variability due to our treatments plus some error by our estimate of just plain sampling error. And this has actually changed a little bit because the way that we've estimated error has changed a little bit. For the repeated measures ANOVA, this has become our variance between treatments. Remember, MS stands for mean squared, which is our name for variance in ANOVA. Our variance between treatments, so the variance between our conditions or our time points, divided by our variance error. So this has changed. Before it was variance between divided by variance within. Now it's between divided by error. Can anyone tell me why? Why did we change the denominator? So here you have up here, here's between before. Yeah, we have to account for the extra information that we have. Good job, Xenotime, right? We have more information now. Within, we know where some of that variance came from now. Before, with the between treatments ANOVA, we didn't know anything that was in the within variance. We didn't know why participants differed in the same condition at all, because we couldn't account for individual differences. We only had one piece of information for each individual. But now, we can account for individual differences. I know, hey, this individual is always high on depression, or always high on anxiety, or always like has a very fast reaction time or something like that. I can factor out individual differences. So I don't want to like treat stuff that I know, like I don't want to treat variance I know where it came from, those individual differences as error. It's not error. I know what it's from. So I've changed my MS within to only contain error, because I've explained some of the MS within. That's why we've changed this. The way that we're estimating error has changed. Before, the entirety of MSW was all sampling error as far as we were concerned. Now, only the MSE slice of the MS within is error. We know where the rest came from. We're only dividing by error. Does that make sense? Does that make sense why we switched it up? I think, yeah. I think it clicked for Xenotime, but I do want to make sure to check in on everyone, see how we're doing. I hope that we're doing okay. Yep, makes total sense. Beautiful! I am so glad. I'm so glad. Thank you, Astrologicos. This makes me delighted. Did you know that we only have 4 slides left? And then I can get back to my webtoon? Not that I don't enjoy streaming. I'm just... You know how... I don't know how many of you are here during like the rigging stream, but Fi was talking about how I lock in. I lock in, and currently I'm locked into that webtoon. It is taking all of my willpower to stay here and talk to all of you and not... Oh my gosh, I looked at my phone. This was a mistake. Okay, let's keep going. I'm exerting every ounce of self-control I have in my tiny, tiny body. All right. So here's our source table. These are all the formulas that you would need to calculate all of the types of variance that we have in the repeated measures ANOVA, calculate the F ratio in it, calculate all your degrees of freedom, all that good stuff. The way that you decide whether to reject or fail to reject the null is pretty much the same as it was before. You look up your critical F value using your degrees of freedom between, and this kind, your degrees of freedom error. You always use the F table with the degrees of freedom that you use to calculate the numerator of the F ratio. In this case, sum of squares between. And the degrees of freedom you use to calculate the denominator of the F ratio. And in this case, the denominator of the F ratio is MS error instead of MS within. So we're using the degrees of freedom between and the degrees of freedom error to determine our critical value. Once we've done that, compare the F value we calculate to the critical value. If our F value is bigger than the critical value, we reject the null. There is a difference here. If the F value we calculate is smaller than the critical value, we fail to reject the null. We can't conclude that there's a difference. I'm thinking of that scene in Christmas Carol where they're bound up with a bajillion change in weights. It's Mylan with webtoon. It feels that way. Just a little bit. It feels like once I catch up to this webtoon, just watch. It'll be like Rock Lee dropping his weights in the fight against Gaara. Except that's a joke because the webtoon is based on a web novel, and that means once I finish the webtoon, I have to go read the web novel. There is no safety. There is only pain. Because you know what happens when you're done with the web novel? Now you can look at the fanfic and the fan art without getting spoiled. There is no freedom. Freedom is an illusion. Anyway, let's say you... yeah, I googled it after seeing your tweets and saw multiple versions and numbers in the hunt. There are over 500 chapters of the web novel and over 200 chapters of the webtoon. They've also announced the trailer came out for a live-action adaptation of it, and an anime adaptation has been announced. I have so much material. Not just now, but in the future there will be more to do. Read it, make more fanfic to chain my identity. Oh my gosh, you would write fanfic just for me? I will read the fanfic. I will read the fanfic with gratitude. Most of what I read during my time in grad school was honestly fanfic, because it's much lower buy-in, because you already know all the characters, so they don't need to set everything up. Water and I got flashbacks by shipping fan arts for any webtoon I reviewed without my consent. I'm so sorry, Water. Fans that ship are intense. Fans that have a ship are some of the most motivated people that I know. The curse is still active. The live-action adaptation will be garbage. It's entirely possible, unfortunately. Is that a promise, lol? It is a promise. I will read any fanfic that you write. I left to get to what are we got into fanfics, lol. I'm so sorry. I don't know how it came to this, but I don't think I'd made any attempt to stop it. I think it's my fault. Statistically rigorous fanfic. I would love that. I would love some statistically rigorous fanfic. What if I wrote a stats textbook, except it was fanfic? No. I've got to write like one of those like 200k word long fanfics on Archive of Our Own that's like for a really popular ship. But then by the time you get to chapter 3, you start to realize that this is actually a statistics textbook. It's just it slowly dawns on you, wait, I'm learning. Time to write the most low quality and boring fanfic ever. I don't think that's possible. I don't think that's possible. I have encountered some really it's probably okay to say this because I don't think the authors put any effort into it. I think that was kind of the point. I've encountered some fic that you would have to make extreme effort to write worse than that because they clearly put extreme effort into making it that bad. This is the greatest idea ever. Secretly teach stats. Yeah, I'm not doing it very secretly right now, but look, I am an anime character and I'm teaching you stats. So that's one level of infiltration of statistics, and you're teaching shipper statistics. That's giving them more arsenal for their stuff. Yeah, I had a thought. I had a thought a while back about trying to turn a physics textbook into some form of more interesting medium. Right? You know, I've thought for a while about doing a Minecraft world where I use Minecraft to teach statistics, like building distributions out of blocks and stuff, like using item frames to build a distribution of possible drops from, like, say, lapis ore with fortune, or varying levels of fortune and stuff like that. That would be really fun. We watch Mylan's Rain to reach for a safe for class word. Do you think I care about safe for class words? Okay, I do to some extent, but like... I've probably sworn during this lecture already 3 or 4 times. There's a reason every time I create these any video, even these stats ones, I just not for children. Not that I think repeated measures t-test should be given to small children either. I don't think that's good for their development. We tried to make Mathcraft in middle school. It was a total disaster. Well, clearly, I'll just be better than that. I'm just built different. I don't know about you. Most of middle school friendship politics not actually... There you see. Only just got the first Herba Mystica. Oh, I'm so sorry. They do have the education... I've never played the education edition. See, the problem with most of this... I love Minecraft. I will play it for hours. But most people play on Java. And you can only play Java on the PC. And I get really motion sick when I try and play games on the PC. Not that that stopped me from playing Minecraft on my PC, but it has stopped me from getting nearly as productive as I have in other places, which is unfortunate. That's the main thing stopping me from doing more Minecraft stuff. I'm sorry. Okay, anyway, So let's say you reject the null on your ANOVA. What do you do next? Supposedly the Minecraft Education Edition is kind of stupid. I don't know. I've heard some good and some bad things. I think technically Bedrock has more players. They just lean longer. Yeah, I play Bedrock because I can play it on my console, and I don't get as motion sick on my console. The problem is I want to play with certain other individuals, and the certain other individuals I want to play with play on Java. That is my greatest downfall. Everybody that I want to play Minecraft with plays Java, and therefore I must either play alone or suffer motion sickness. It's the law of the land. Just let me play on Java servers through console. Expensive solution, a Steam Deck with MC Java. Oh, can I do that? Is that possible? Drama mine to play Minecraft. Is it... Could I play Java on a Steam Deck? There are ways to crossplay, but they're very roundabout, yeah. I've also know there's ways I can set up my controller on my PC, like, and I wonder if that would help. I've tried it before, and it didn't help too much, but I'm not sure. Anyway. Okay, so let's say you reject the null on your repeated measures ANOVA. Or just knock on the doors asking to build empathy until they agree to play Bedrock with you. I better go knock on some doors. Some people are in danger. Your best bet is crossplay with Geyser. I've never heard of Geyser. I'll have to check this out. I'll have to check, because if I can play on a Java server from my console, it is all over for everybody else on that server. They will log on and I will be online. Always. They'd be in grave danger. Then again, my carpal tunnel's already bad enough. I should probably hold back. Though you're limited to vanilla and the plugin has to be installed on the server. Oh, that makes sense, yeah. No, you're fine. You're fine. I'm sorry. I need to log it. This is me. This is my problem with getting distracted and going on tangents. This is not a you problem. This is a me problem. What's the psychologist B theorem members in gaming all night? You're one to talk, fine. You're one to talk. You have no right to say that. I see how much I see your status on Discord. Don't worry, I go off the rails every live stream I do. That is comforting. Okay. You reject the null on your repeated measures ANOVA. What are your options? That counts. AFKing at the Frog Lake Farm counts. The scuffness brings the charm. I'm glad. Okay, all right. So, you reject the null on your repeated measures ANOVA. You have a couple options. You can still do planned contrasts. You can just use MS error instead of MS within. I think there are technically ways to do Shafei and Tukey tests as well for following up a repeated measures ANOVA, though I'm not as familiar with the Tukey version. Shafei, I think, would be fairly straightforward. It would be the same as a planned contrast, just replacing MS within with MS error. But I'm going to give you an additional post hoc test, and that is the Bonferroni post hoc test. Bonferroni is a type of post hoc correction on your alpha value that you can actually do with any statistical test that produces a p-value. This is not restricted to ANOVA. You can do this on correlations. I've done it on correlations. That's where I've primarily used it. You can do it on t-tests. You can do this on regressions. You can do this on whatever. My guy, Bonferroni. Yeah. Me and Bonferroni, we go way back. I don't know if I want to say that because I don't know what kind of guy Bonferroni actually was, but what do you do after I reject the null on your repeated measures ANOVA? AFK gaming! That's what you do if you failed to reject the null on your repeated measures ANOVA. You didn't find anything, you failed to reject the null, time to go game. Go AFK at the Frog Lake Farm and drink a soda or something. Drink some hot chocolate. Eat a meal. Anyway, so what is a Bonferroni correction? A Bonferroni correction is dividing your alpha level, which is usually in psychology, and I think a lot of other places, alpha is 0.05, by the number of post hoc tests that you're doing. For example, if I'm doing 3 follow-up tests, So let's say I'm doing 3 t-tests because I had 3 conditions. And my alpha is 0.05. I divided that alpha of 0.05 by 3 because I'm doing 3 follow-up tests, which means now to reject the null, rather than p being less than 0.05, I need p to be less than 0.017. It makes it a lot harder to reject the null. This is a very conservative correction. It really reduces your chance of a type 1 error. It reduces your chance of getting a false positive, but it just makes it harder to reject the null in general. So it also increases your chance of a type 2 error, a false negative. So a lot of people don't like this. It is by far the most conservative test that we've talked about, which means you're a lot more likely to miss things if you're using this. And so some people don't like it. Soda, right? I'm gonna be honest, soda is my vice. I'm already severely, like, socially anxious and self-conscious about how I act when I'm completely sober. Like, his wiki page doesn't seem to have anything bad, but he was an Italian in the 20s and 30s, so... I know a lot of people who hate him solely because of the Bonferroni correction. I feel like I know quite a few people who would say he was a horrible person for this alone. Like, regardless of anything else that he did in his life, people would hate him because of this solely. Like, that's the level that this is on. I don't think it's a problem. I don't think it's bad. I believe we've established that Phi also is totally fine with Bonferroni corrections. But I have actually encountered reviewer 2s that got mad at me for doing Bonferroni corrections, which is wild to me. It's wild to me. Why would you be mad that I did a Bonferroni correction and still got it significant? It affects me if I got a false negative. It doesn't affect you, reviewer 2. Shouldn't you be happy that my results hold up under a Bonferroni correction? Oh my god. I'm not a geneticist though, so maybe they're molding. I just smile and nod. Fair. Okay. So, some additional notes on Bonferroni correction, this time with memes. Bonferroni corrections are very, very conservative. They make it very difficult to find a significant effect, which raises your risk of type 2 errors. And here's our memes. When you choose Bonferroni correction instead of FDR, which is another type of follow-up test, on 10 plus sets of comparisons and watch those significant p-values disappear. We've got this, me and the significant boys. Then me and the significant boys after the Bonferroni correction, only one of them is left because p is less than 0.05 isn't good enough anymore with a Bonferroni correction. Bonferroni correction on a large number of group comparisons, all of these type 2 errors. Yeah. There, you know, Bonferroni correction, more like bonfire correction, burn that paper. I admit, I'm not, like, I don't think that paper that I did them in is actually all that great. I don't think it holds up very well, but me and the boys are a perfect meme. Yeah. It's so funny. Like, when I first started teaching stats, I decided that I wanted to have, like, memes to help students understand the concepts, and I went looking for stats memes. There are way more Bonferroni correction memes than statistics memes on almost any other topic. It's wild. Like, that is how strongly people seem to feel about Bonferroni corrections. I found so many more Bonferroni correction memes than, like, memes about even, like, much more basic, well-known statistics stuff. Like, that is where we're at. It's wild. It's a great meme. I remember enjoying them a lot when I was a kid. all these lovely memes. And that's actually all I've got. That's all I've got. Like I said, I don't really have a lot of repeated measures ANOVA because they're honestly not that commonly used. Like, most of the day, people don't actually use ANOVA all that much these days in general. They mostly just go straight to regression, which technically ANOVA is a type of regression anyway. So, like, but, like, especially repeated measures ANOVA, they're pretty rare these days. So I didn't want to spend too much time on them. But, like, if you read an older paper, and maybe the odd newer paper, you might still encounter them as well. So, figured I'd talk about them. I definitely wanted to talk about them because I wanted to set up for what's coming on Wednesday, which is a factorial ANOVA. And factorial ANOVAs are much more common, I'd say, than the between or within ANOVA, or between or repeated measures ANOVAs. Because factorial ANOVAs allow you to do interactions. Just found shiny deerling, so far 2 shinies and only a single Herba Mystica. Oh no. Oh my gosh. Do you have a shiny chart? I'm curious. You're making me want to play. You're making me want to go shiny hunt, but that's the problem. The single worst thing for my carpal tunnel is the Switch. Nothing makes my wrist hurt more than the Switch. So, like, I really want to play and hunt shinies too, but when my wrist is already like this, that's a horrible idea. So I'm gonna live vicariously through you, okay? Okay? Is that all right? I'm gonna live vicariously through you, and I will give you my shiny hunting luck for the night. I'm not gonna do any shiny hunting, so take my shiny hunting luck, take my Herba Mystica luck. You can have them. Yeah, and I checked and my shiny living dex is now at 37%. That's pretty darn good. Congratulations. Are you going for all forms too? So like for all seasons of Deerling, or just like just all Pokemon and not worrying about the forms bit? Because I know you were doing like Rockruff and stuff, and the morning or day and night. It just used takedown. I hope you saved. I hope you saved. You need to switch emulator. I hear that Nintendo says that they are not illegal. That sounds suspect. I think what I just need is a different control for my Switch. Oh, you didn't? I guess the main comfort is that you did already have one, so maybe that's okay. You didn't lose a whole lot, at least. I guess that's kind of the best case scenario if that happens, is if you didn't save and a Pokemon makes itself faint, at least you already have that shiny. Anyway. Yeah, we're done. We're done. We're done for today. Any questions? Comments, concerns, anything you'd like to talk about before I go disappear into the world of Webtoon and you never see me ever again? It could happen. That's a lie. I have another lecture scheduled and I intend to hold myself to that, but oh my gosh. I'll probably be caught up. What is the Webtoon? Omniscient reader's viewpoint. Is there a difference between a Webtoon and a webcomic? Webtoon is a specific website used for hosting webcomics. So it's like a specific company. A webcomic, there's also a bit of a difference in formatting. Webtoon tends to use like the infinite scroll formatting that's most optimized for phones and stuff. So a lot of webcomics that I've encountered do page by page, sort of like either as a comic strip format like you'd find in newspapers, or in, you know, comic page format like in a graphic novel or an issue of like standard American comics or something like that, or like a zine. Most webcomics take that format. Webtoons, yeah, they're designed for infinite scroll. So each episode is almost like it's separate images for the sake of loading, but it looks like one giant continuous image that you scroll down. So the panels tend to be only one. The pages tend to be only one panel wide, but they're many, many, many panels long. So Webtoon is the website, and then generally comics on Webtoon tend to be formatted pretty differently than more traditional webcomics or other webcomics. Yeah. Oh. I also set my manga viewing to Webtoon's infinite scrolling style because it's so superior. See, I like to read my comics, well, if I can read them, a physical copy, I much prefer that. But I don't like the infinite scrolling because I tend to use my computer more than I use my phone. So for me, infinite scrolling is actually less convenient, which it's been an adjustment reading Webtoon style comics because I had to move to my phone. They're such a pain to read on the computer, and I really would prefer to read on the computer to my phone. So I don't like the infinite scroll most of the time. Oh gosh. Oh, I have a horrible itch and it's not going away. And the itch is to read more of this webtoon. I like just having to remember a page number and going straight there. That is nice. A lot of like modern comic viewing websites say I prefer to read manga. Hell yeah. It is so small too, though. That's one of my problems with it's small on the phone, but it's also small on the laptop. And like on the laptop, you can't zoom in as much. That's why I like the physical ones. I much prefer to read my manga as physical copies. The one problem with that, of course, being the binding can sometimes make the inner parts of the pages a bit harder to see. But I much prefer my manga in physical format. But of course that gets expensive. This is why I have 4 bookcases and they're all full. I like physically I've wasted so much money on D&D books. I feel you. I feel you. I don't even want to know how much money that I have spent on manga. I'm scared to look behind me where all of my manga is. Because I just don't want to think about how much I own right now and how much it must have cost. Oh, it's painful. Oh, but it's so much nicer to read it physically if you can. Anyway, I think I'm gonna call it here for today. So I can read my webtoon and also just get some rest. I think we all need some rest. Scary Intimidating Horse manga collection sitting at the bed. That's basically what my life is like right now. That reminds me, I have a big session back to my campaign after hiatus in less than 14 hours and still need to prep. You should do that. Yeah, good night, y'all. Good night. Have a good night. Take care, everyone. I will see some of you if you are up for it. I'll see you on Wednesday for when we start talking about Factorial ANOVA and interactions. If not, that's okay. Yeah. Good night, everyone. Take care. Bye-bye.